In this short video, we look at section 11.5. This section is related to planes and specifically constructing the equation of a plane. What we're looking at essentially is trying to find the equation of a plane, okay, that maybe you would recognize to be of the form, x plus 2y plus 3z is equal to 4. Here's the equation of a plane. Or possibly it could be of the form z is equal to negative x plus 2y. Both of these are equations of planes that we just kind of recognize, okay, as planes. Okay. But a more specific question is, how would you construct a plane, maybe, for example, like actually find the equation of a plane, not just recognize the equation of a plane, but find a plane, maybe, for example, that goes through the three distinct points P, Q, and R. How could you find that? Okay. Or, for example, maybe your plane, right? The plane that you're looking for, okay, goes through a point P, right, and maybe has is normal to some vector n. Okay, so this normal vector is really what makes a plane, and what makes a plane change its shape or change its direction and angle. So if you were to change the normal vector and maybe keep, maybe put a point P over here, this plane could actually, would actually change its shape. These problems get kind of hard to draw here, but it's the normal vector that changes the direction and tilt of the plane. Okay, so it would be possible to find the equation of a plane that goes through a point P and also has a specific normal vector that you're looking for. Okay, so 3 points determine a plane, but really what it comes down to is a point that the plane goes through, and it's the normal vector that controls what the plane looks like. Because if you have 3 points, you can construct 2 vectors, and those 2 vectors you could use to create the cross product to find the normal vector. So it's the normal vector and a point that really, the key takeaway is that if you know a point in the plane and you can find a normal vector for that plane, that's what determines the equation. Okay, so let's set our sights on constructing the equation of a plane that goes through a given point. Okay, typically the point that you're given is called x naught, y naught, z naught. This is the point that you're interested in. Okay, let's call it the point P. Okay, and we'd like to find all the possible x, y, z values, which we don't know. We'd like to find all the possible x, y, z values so that when you draw a vector from the point that you're interested in to any other point that is in this plane, x, y, z is a thing that can move, so here a point that can move in the plane. So here are 2 vectors. Why are those vectors in the plane? They're in the plane because here would be a normal vector, and the 2 vectors that are in the plane are perpendicular to some normal vector. Okay, so this gives us our strategy for constructing the equation of a plane. Essentially, what you need to do is first find a vector from the point that you're interested in, x naught, y naught, z naught, to any point in the plane x, y, z. Okay, so the point, let's call this Q. So what you're looking for is to construct a vector from P to Q, okay, which is going to be x minus x naught, y minus y naught, and z minus z naught. So we're looking for all the points x, y, z so that when you create a vector from the point that you're interested in to some point x, y, z, q, that they must dot product with the normal vector, and since the normal vector is perpendicular to this plane, that you get 0 as the dot product. Okay, so this gives us our strategy. Let's say that our normal vector is some vector n1, n2, n3, 3 entries. This gives us our strategy right here, that I want to find all the values of x, y, and z such that the dot product with the normal vector gives 0. So here comes the equation of our plane, n1, x minus x naught, this times this, the normal vector times x minus x naught, the second entry of the normal vector times y minus y naught, plus the third entry of the normal vector z minus z naught, equal to 0. Here's the equation of your plane that goes through the point that you're interested in and has normal vector n1, n2, n3. Okay. So as an example here, let's say that you want to construct the equation of a plane that goes through the point P that you're interested in. Maybe it goes through the point 1, 2, 3. And let's say that for some reason you know the tilt of this vector, the tilt of this plane has normal vector 3, 4, 5. Well, 1, 2, 3 is therefore our point x naught, y naught, z naught, and 3, 4, 5 is our n1, n2, n3. So the equation of this plane is 3 times x minus 1 plus 4 times y minus 2 plus 5 times z minus 3 equal to 0. There's the equation of your plane in implicit form. You could expand this out, 3x minus 3 plus 4y minus 8 plus 5z minus 15 equal to 0, which would lead to 3x plus 4y plus 5z equal to 26. There's another form of your plane. Or you could solve for z to give 26 minus 3x minus 4y divided by 5. There's the explicit form of your plane. Okay. So if you can find a point of interest, a point that you know is in your plane, and if you somehow can find a normal vector, then that is the necessary information to find a plane in its equation in implicit form here, which can be solved for the explicit form. I'm sorry, this is implicit form, and here's another explicit form. So let me show one example of a not quite as straightforward example, one that requires just a few more steps to construct the equation of the plane for. Okay. Let's say that we're trying to find the equation of some plane. This plane is going to be in three-dimensional space, and we know something about this plane, that we want this plane to go through the point -1, 2, 3. This is your point of interest. Okay. And this plane also has to contain the line. There's a line that this plane has to contain, and it's of the form -1 plus 2t, -2 plus 3t, and then 3 minus t. This is also known as -1, -2, 3, plus 2, 3, -1 times t. So point plus v times t. So here we have this line, and we'd like to construct the equation of this plane here. Okay. Keeping in mind that the key ingredients we need a point, which we have. We'll call this the point P, -1, 2, 3, so we're good there. And we also need a normal vector for this plane. It always comes down to finding the normal vector? Well, the normal vector can be constructed by perhaps finding 2 points along this line. So now I have 3 points in the plane. Okay, so the first step there would be to find 3 points in the plane. Okay, the second step would be to maybe construct 2 vectors in the plane. And then see, by using the cross product, that cross product would give me the normal vector for the plane. Okay, that would give me the vector that's perpendicular to both the 2 vectors in the plane. Okay, so if we try to act on this information, okay, follow this process, maybe here's a point Q and here's a point R. We know the 3 points in the plane, P, one of the points, -1, 2, 3. Another point could be the line at time 0. The line at time 0 is simply -1, -2, 3. And another point could be the line at time 1, which would give us 1, 1, 2. Okay, so there are your 3 points in the plane from which you can construct the 2 vectors in the plane. So if we have the 3 points, then let's construct the vectors PQ and the vectors PR. Okay. So if we have the point P, Q, and R, we need to construct 2 vectors starting at P, so that would be Q minus P and R minus P. Q minus P turns out to be 0, 4, 0. Sorry, 0, -4, 0. And then R minus P is +2, -1, -1. Okay, so there are your 2 vectors. Okay. Part C would be to construct the normal vector as the cross product of those 2 vectors. Okay. That would give I, J, and K. 0, -4, 0, and 2, -1, -1. Constructing the cross product there, the answer comes out to be a vector. You will have 4, a negative number in the J entry, so you will get 0. And then for the K entry, we get +8. So 4, 0, 8. So there's your normal vector. And we know a point already in the plane. I think we decided that that was -1, 2, 3. And from there we can construct the equation of our plane as 4 times x plus 1 plus 0 times y minus 2 plus 8 times z minus 3 equal to 0. There is the equation of your plane that goes through these points, 3 points, and the P and Q points were the points that were along the line. So here is our plane that contained the line and also went through the point P. And that is the equation of the plane. And so ends this first video.